Welcome to the deep dive.
Uh,
Today we're going to be going deep into Bitcoin
oh, Bitcoin.
with the book Mastering Bitcoin, 3rd edition by Andreas M. Antonopoulos and David A. Harding.
Oh, a classic.
Yeah, and this book is dense.
It is.
So we're going to try to extract those golden nuggets for you and serve them up.
Yeah, think of us as your Bitcoin miners.
Perfect.
We're sifting through all the complicated stuff
Exact.
to bring you the shiny treasures.
And speaking of golden nuggets, I was reading the preface, and Andreas talks about when he first discovered Bitcoin back in 2011.
Okay.
And he called it nerd money.
Oh, wow. Can you imagine?
Can you believe it?
Like missing the boat that badly?
I know, and it just reminds me of the, early days of the internet.
Right, when people thought it was just a fad.
Exactly. People just didn't fully grasp its transformative potential.
It's like history repeating itself, but with Bitcoin this time.
It really is, but thankfully Andreas did eventually have his aha moment. And he realized Bitcoin wasn't just about digital cash, but a network of trust.
Network of trust. That's interesting.
And that really is, when you think about it, what makes Bitcoin so revolutionary.
Right, because it's not just about the money itself.
Exactly.
It's about changing how we think about value and trust.
So let's get practical. How does this actually work? And the book walks us through a really simple scenario with Alice, who buys a podcast from Bob's online store using Bitcoin.
Okay, a classic example.
Yeah, and what I think is really fascinating is that this transaction happens without any central authority like a bank.
Right, it's all peer-to-peer.
Exactly. So let's break it down a little bit. So Alice's wallet creates a transaction with inputs. What are these inputs?
So inputs are basically the Bitcoin that Alice is spending.
Okay.
They point back to previous transactions where she received those Bitcoins.
Okay.
So you can think of it like a trail of breadcrumbs.
Interesting. A digital trail?
Yeah, leading back to the origin of those Bitcoins.
Ooh. Okay, and then we have outputs. So in this case, one output sends the correct amount of Bitcoin to Bob's store.
Right.
But what if Alice sends more Bitcoin than the podcast costs? Where does the rest go?
That's where the second output comes in.
Okay.
It sends the remaining Bitcoin back to Alice's change.
Oh, like digital change.
Exactly. Just like you'd get change back if you paid with cash.
I see.
It all works out quite neatly.
So by the way, speaking of amounts, I learned a fun fact. The smallest unit of Bitcoin is called a Satoshi,
Oh, yes. It's a little tribute to Satoshi Nakamoto.
the mysterious creator.
Exactly. We still don't know who they are.
Okay, so we have our transaction with its inputs and outputs all set up.
Okay.
What happens next?
Well, now the transaction needs to be added to the blockchain
Okay, blockchain. Here we go.
to become official.
Okay.
And this is where the miners come in.
All right. Mining, the part that always kind of trips me up.
It can be a bit of a head scratcher.
Can you break it down for us?
Okay, so imagine mining as a giant decentralized lottery.
Okay.
Miners are constantly competing to solve complex mathematical problems.
So they're all just churning through these problems, like hoping to win the jackpot.
Exactly. And the first miner to solve the problem gets to add a new block of transactions to the blockchain.
Okay.
And that block includes Alice's transaction.
Got it.
And for their efforts, they get rewarded with newly minted Bitcoins, plus any transaction fees.
So it's like a combination of luck and resources.
Exactly.
The more computing power you have,
The higher your chances of winning.
the more likely you are to win that Bitcoin lottery.
Exactly.
Clever system.
And it's a system that has proven to be very secure.
Okay, so let's talk about Bitcoin addresses,
Right.
because these are crucial for receiving Bitcoin, right?
Absolutely. It's like your digital mailbox for Bitcoin.
Okay.
But here's the interesting thing. These addresses aren't registered anywhere in a central database.
Wait, really?
Yeah.
How does that work?
Each address is derived from a private key,
Okay.
which is a secret string of characters.
That only you should know.
That only you should know. Exactly.
So if you lose your private key, you lose access to your Bitcoin forever.
Poof. Gone. That's it.
Oh, that's a lot of pressure.
It is. That's why it's so important to keep your private key safe and secure.
It's a good thing they don't use IP addresses anymore like they did in those early Bitcoin versions.
Oh, can you imagine?
I know. Anyone who knew your IP address could just send Bitcoin to you without your knowledge.
It would be chaos.
It would be a security nightmare.
A total nightmare.
So, okay, we have private keys generating these unique Bitcoin addresses.
Right.
What happens next?
Well, those private keys actually generate something called public keys first.
Okay.
And public keys are essentially points on an elliptic curve.
Now you're just showing off.
I know, but don't worry. You don't need to understand the complex math behind it.
Oh, thank goodness.
But The important thing to know is that they play a key role in the whole system.
But why do we even need these public keys if we already have the private key?
Well, it's all about managing those keys efficiently.
Okay.
Public keys, in their raw form, are really long and complex.
Okay.
That's where hash functions come in.
Okay.
They take that complex information and condense it into a more manageable chunk.
So it's like a digital fingerprint of the public key.
Yeah, that's a good way to think about it.
Okay.
And here's where it gets even more interesting. A single private key can actually generate different Bitcoin addresses
Really?
based on whether the public key is compressed or uncompressed.
So I can have multiple addresses linked to a single private key.
Exactly.
That's kind of cool.
It is, and it doesn't affect the security, but it can be a bit confusing if you're not aware of it.
Okay, I think I'm following so far.
Good.
So let's talk about wallets.
Okay, wallets, everyone's favorite topic.
Yeah, we know they're essential for storing Bitcoin, but I have a feeling there's more to them than meets the eye.
Oh, absolutely. Wallets have come a long way since the early days of Bitcoin. And the book goes really deep into the evolution of wallets, especially HD wallets, which stands for hierarchical deterministic.
HD wallets, what makes them so special?
Think of an HD wallet like a family tree of keys,
Okay.
all stemming from a single seed,
And that seed is usually...
a 12-word recovery phrase.
Right, which you need to keep very safe.
Exactly. It's like a master password for all your Bitcoin.
So instead of backing up countless individual keys, I just need to remember these 12 words.
Exactly. Much easier to manage, right?
That's a lot less to write down.
And the beauty of HD wallets is that they can generate an almost unlimited number of keys from that single seed.
So it's like having a vault with endless compartments, all secured by one master key.
You got it.
Pretty ingenious.
It is, and it gets
Oh.
even better.
Oh, there's more.
HD wallets also utilize something called extended public keys,
Okay.
which allow websites to generate unique Bitcoin addresses for each customer.
Wait, so a website can create an address for me without even knowing my secret key.
Exactly. Pretty cool, right?
How does that work?
It's a clever cryptographic trick that enhances security for both the customer and the merchant.
Okay.
The website essentially creates a branch on your key tree, but they only have access to the public part of that branch.
So it's like they're given a limited key.
Exactly. Just enough to create an address for you.
Okay, so HD wallets aren't just about personal organization. They actually have huge implications for businesses, too.
Right. They're very versatile.
This is way more than just simple storage.
Absolutely. And speaking of security and functionality, this brings us to another fascinating topic, Bitcoin scripting.
All right, scripting, is this where I need to brush up on my coding skills?
So don't worry, it's not about complex programming.
Oh, good.
Bitcoin scripting is more like a set of rules
Okay.
or conditions that need to be met to unlock and spend Bitcoin.
So like an if this, then that kind of situation.
Exactly, you got it.
Okay.
So we talked about the multi-signature example earlier, requiring 2 out of 3 people to sign off before funds can be accessed.
Right, like a digital safety deposit box.
Exactly.
So these output scripts are locking the Bitcoin.
Yeah.
And input scripts are unlocking them based on these predefined conditions.
You got it.
Elegant system.
It is. And Bitcoin scripting allows for a really wide range of use cases.
Like what?
Oh, everything from simple transactions
Mhm.
to more complex smart contracts.
Smart contracts on Bitcoin. I didn't realize that was possible.
Oh, yeah. It's a whole other world of possibilities.
So scripting really opens up a lot of doors.
Absolutely. And as Bitcoin continues to evolve, we're seeing even more innovative uses of scripting emerge.
This is just the tip of the iceberg, isn't it?
It is. We've only just scratched the surface.
Okay, so before we go any further down that rabbit hole,
Okay.
let's talk about a couple of key upgrades that have significantly impacted scripting.
Oh, yes. The famous SegWit and Taproot.
Yeah.
Those
Yeah.
are game changers.
Okay, but how do they actually relate to scripting?
So SegWit, or segregated witness, was a big deal.
Yeah.
One of the things it did was fix an issue called transaction malleability.
Transaction malleability, that sounds like a problem.
Oh, it was a problem. It meant that small details of a transaction could be changed
Oh.
without invalidating the signature, and that posed security risks.
I see.
And it also limited the development of more complex scripts.
So SegWit made Bitcoin more secure
Yes.
and paved the way for more advanced scripting applications.
Exactly.
And then Taproot came along
Taproot, the next big thing.
and took things even further. How so?
Well, one of the key features of Taproot is that it allows for more complex scripts to be executed more efficiently
Okay.
and with greater privacy.
So even complex transactions appear more straightforward on the blockchain.
You got it.
That's pretty impressive.
It is. Taproot has been a major step forward for both privacy and scalability in Bitcoin.
So I'm seeing a pattern here. Bitcoin is constantly evolving and improving.
Absolutely. It's a living system.
It's exciting to see how these upgrades are pushing the boundaries of what's possible.
And it's all thanks to the amazing developer community behind Bitcoin.
Right, constantly working to make it better.
Exactly.
So this brings us to something that's really crucial for anyone who's serious about Bitcoin,
Okay.
and that is running a full node.
Ah, yes, the ultimate power move.
Now, I have to admit, I'm a little intimidated by the technical aspects of it. Can you demystify it for me?
Sure, think of running a full node as taking control of your Bitcoin experience.
Okay, I like the sound of that.
So a full node downloads the entire Bitcoin blockchain,
The entire thing.
the whole thing,
Wow.
and independently verifies every single transaction.
So it's like having your own personal auditor,
Exactly.
ensuring the integrity of the network.
You got it.
So instead of relying on others to tell me what's happening, I can verify it for myself.
You become your own bank.
That's powerful.
It is. It's the ultimate level of security and privacy.
Okay, I can see why the book really encourages running a full node, especially if you really care about privacy and security, but I imagine it takes a lot of storage space and bandwidth, right?
It does, but it's becoming increasingly accessible as technology advances.
Okay.
And the benefits really do outweigh the costs, especially if you believe in those core principles of decentralization.
It's definitely something to consider.
Definitely something to think about.
Now let's talk about transaction fees.
Oh, yes. The fees, everyone's favorite.
I understand they're important, but I'm still a little fuzzy on how they actually work.
Okay, so transaction fees are basically what incentivize miners to process those transactions
Okay.
and secure the network.
So they're like little tips that you add to your transaction
Exactly.
to get it included in a block faster.
You got it.
So the higher the fee, the faster my transaction goes through.
Generally, yes, but it's a bit of a balancing act
Okay.
because higher fees eat into your Bitcoin holdings,
Right.
while lower fees might mean you have to wait longer for confirmation.
So it's a trade-off between speed and cost.
Exactly.
Okay, now this brings us to something that's really fundamental to Bitcoin, consensus.
Yes, the heart of the matter.
Because this is a system with no central authority.
Right.
So how does it manage to agree on a single version of the truth, the blockchain?
Well, it's one of the most ingenious aspects of Bitcoin.
Okay.
It all boils down to proof of work, or POW.
Right, POW. I've heard that term before. Can you remind me how it works?
So remember how the miners are constantly competing
Yeah.
to solve those complex math problems?
Yes.
That's proof of work in action.
Right?
The longest chain of blocks, the one with the most accumulated computational work, is considered the valid blockchain.
So it's like a constant race to build the most powerful chain.
Exactly.
And because it requires so much computing power, it's incredibly difficult for anyone to try and manipulate it.
Exactly. It would take an astronomical amount of resources to try to rewrite history.
Okay, that makes sense.
And it's this competitive process that really makes Bitcoin so secure and resilient.
But the book also talks about something called a 51% attack, which sounds a little ominous.
It does sound a bit scary, doesn't it?
What exactly is a 51% attack?
Okay, so it's a hypothetical scenario, thankfully,
Okay, good.
where a single entity somehow gains control of more than 50% of the network's computing power.
Okay, and if that were to happen?
If that were to happen, they could potentially double spend Bitcoin, reverse transactions, all sorts of bad stuff.
This does not sound good.
No, it doesn't, but thankfully,
Thankfully.
a 51% attack on Bitcoin is incredibly unlikely.
Okay.
The cost and effort required to control that much computing power would be astronomical.
That's reassuring.
And not to mention the potential backlash from the community.
Right, people would notice.
People would definitely notice.
Okay, so it seems like Bitcoin is designed to be pretty resilient.
It's incredibly robust.
But speaking of challenges and changes, can you explain the concept of forks?
Forks, yes, they can be a bit confusing.
They've always been a bit of a mystery to me.
Okay, so essentially, a fork occurs when there's a change to the Bitcoin protocol.
Like an update.
Kind of, but it can happen intentionally as an upgrade or sometimes unintentionally due to a bug or a disagreement within the community.
Okay, I've heard terms like hard fork and soft fork thrown around. What's the difference?
So a hard fork creates an entirely new blockchain
Okay.
that's incompatible with the previous chain.
Like a permanent split.
Exactly, like a permanent split in the road. Bitcoin Cash is a good example of a hard fork.
So it creates two completely different versions of Bitcoin
Yes, essentially.
and a soft fork.
A soft fork is backward compatible, so it introduces a change that's accepted by both upgraded and non-upgraded nodes.
So it's more like an update that everyone can agree on.
Exactly.
Okay, so hard forks have led to the creation of new cryptocurrencies,
Like Bitcoin Cash, yes.
and soft forks have allowed Bitcoin to evolve without fracturing the network.
Exactly.
Interesting. So these forks highlight the challenges and complexities of governing a decentralized system.
They do. It's a constant balancing act.
It's like trying to herd cats, but with code.
That's a great analogy.
But ultimately, this process ensures that Bitcoin remains open, transparent, and resistant to censorship.
Exactly. It's messy, but it works.
And that's a good thing.
It is a good thing.
Okay, so speaking of the future, what lies ahead for Bitcoin?
Ah, the big question.
I know mastering Bitcoin doesn't offer a crystal ball, but it must provide some insights, right?
Well, one thing is for sure. Bitcoin is here to stay.
I think we can all agree on that.
It's already disrupted the financial landscape, and it's continuing to evolve at an incredible pace.
But what are some of the key challenges and opportunities that it faces moving forward?
Well, one of the biggest challenges is scaling,
Okay.
finding ways to handle the increasing volume of transactions.
Right, because as more people use Bitcoin,
Yeah,
that
yeah.
network gets more congested.
Exactly.
And we don't want to sacrifice decentralization or security in the process.
Absolutely not. That's the heart of Bitcoin.
So the book mentions things like the Lightning Network and research into more efficient consensus mechanism.
Those are some of the leading solutions being explored.
Can you explain those a bit further?
Okay, so the Lightning Network is what we call a Layer 2 solution.
Oh, okay.
It allows for faster and cheaper transactions off the main blockchain.
So it's like creating express lanes for Bitcoin transactions.
That's a great way to put it.
I like that.
And researchers are also constantly looking into new consensus mechanisms
Okay.
that could potentially increase the throughput of the Bitcoin network without compromising security.
So it sounds like the Bitcoin community is actively working on solutions.
They are. They're not just sitting back.
To ensure Bitcoin can handle mainstream adoption,
That's the goal.
that's encouraging.
It is very encouraging.
But scalability is not the only challenge, right?
Right. Privacy is another big one.
Because while Bitcoin transactions are pseudonymous,
They're not completely anonymous,
right?
and that's something that needs to be addressed.
And I remember the book mentioning techniques like coin join and newer privacy-focused protocols.
Exactly, and those are gaining traction within the community.
That's good to hear.
Yeah, because privacy is essential for ensuring Bitcoin's fungibility.
Right, and protecting user data.
Exactly.
So it's clear that Bitcoin is more than just a digital currency. It's a complex and evolving technology
It's a whole ecosystem.
that has the potential to reshape how we think about money and value.
And mastering Bitcoin is a fantastic resource for anyone who wants to really understand the technical foundations of this revolution.
Couldn't agree more. It's been an incredible deep dive so far.
It has been a journey.
What stands out most to you from our exploration of mastering Bitcoin?
You know, for me, it's the realization that Bitcoin isn't just a technology, it's a movement.
A movement.
It's about empowering individuals, promoting transparency, and challenging the status quo.
I love that. It's more than just code.
Exactly.
It's a vision for a more decentralized and equitable future.
Absolutely.
So as we conclude this first part of our deep dive, I want to leave you with a thought to ponder. If Bitcoin represents the separation of money from the state, what other systems and structures could be transformed by embracing decentralization?
That's a big question.
It is a big question.
A lot to think about there.
So until next time, keep those Bitcoin brains buzzing.
Happy mining, everyone.
Welcome back to the deep dive. Last time we laid the groundwork, exploring the basics of Bitcoin transactions, the blockchain.
Yeah, we even touched on the mysterious Satoshi Nakamoto.
Oh yeah, the legend.
Still out there somewhere.
We also started to see how Bitcoin is so much more than just digital cash.
Right, that whole network of trust idea is pretty profound.
Yeah, it really is.
Makes you think.
So in this part of our deep dive into mastering Bitcoin, I'm really excited to dig deeper into wallets.
All right, wallets, let's do it.
We left off talking about H3 wallets, but I still have a few questions.
In with them.
Okay, so I get the basic idea of a 12-word seed phrase acting like a master key.
Right.
But how does that actually work in practice? Like, how do you go from a phrase to generating all those keys?
Well, the magic's in the math, but thankfully you don't need a PhD to understand the concept.
Okay, good.
Imagine this. You plant a seed in the ground. And from that single seed, a whole tree grows, branches, leaves, the whole shebang.
Okay, I'm following so far.
So that seed, that's your 12-word phrase.
Okay.
And through a clever cryptographic process, this seed is used to deterministically generate a whole hierarchy of keys, your private keys, public keys, and all the addresses they control.
So each new address is like a new branch on that tree,
You got it.
all originating from the same seed.
It's beautiful, really.
Elegant.
And if you ever lose your wallet, as long as you have that seed phrase, you can regenerate that entire tree of keys and regain access to all your Bitcoin.
That's a huge relief, especially compared to, the early days.
Oh, yeah.
Where losing your wallet was like game over.
It was like losing your life savings.
But the book also mentioned something about key derivation paths. What are those exactly?
Key derivation paths. These are like the street addresses of your Bitcoin.
Okay.
Think about it. Your seed phrase allows you to recreate the whole tree, but you need to know which specific branches represent your actual addresses.
Right.
Where you've received Bitcoin.
So it's not enough to have the map to the forest. You need to know the location of each individual tree.
That's a great way to put it.
Okay, so if I'm backing up my HD wallet, I need to back up both the seed phrase and the derivation paths.
Absolutely. Both are essential.
Got it.
Some wallets make this really easy. They provide like a backup file that contains all the necessary information.
Okay.
Others might require a bit more technical know-how.
It's a good reminder that even with these, advanced wallets, you gotta have good backup practices.
Security is paramount.
No system is foolproof.
Words to live by in the Bitcoin world.
Speaking of security, remember we briefly touched on Bitcoin scripting earlier?
Oh, yeah, the locking and unlocking of Bitcoin based on rules.
Yeah, it was fascinating, but I'm ready to go deeper down that rabbit hole.
Right, let's dive in.
So we talked about the multi-signature example.
Right.
Requiring 2 out of 3 signatures to access funds. What other types of scripts are possible?
Oh, the possibilities are pretty much endless. The book delves into some really cool concepts like time locks.
Time locks.
Yeah, and conditional payment.
Time locks so you can schedule Bitcoin to be spent in the future.
Exactly. You can specify like a block height or even a specific date and time before those funds can be accessed.
Interesting. What would that be used for?
Oh, all sorts of things like escrow services
Right.
or inheritance planning.
Wow, that's pretty futuristic.
Yeah, it's pretty cool.
What about these conditional payments?
Oh, conditional payments, these are fun.
How do they work?
So imagine Alice wants to bet on her favorite sports team winning a game.
Okay.
With the conditional payment script. She can lock up some Bitcoin that will only be released if her team wins.
So it's like a self-executing bet powered by Bitcoin.
Exactly. It's amazing what you can do with these scripts.
It sounds like we're talking about smart contracts, but on the Bitcoin blockchain.
Yeah, that's a good way to think about it. Programmable money, baby.
Okay, I'm starting to see why people get so excited about Bitcoin's potential.
It's pretty revolutionary.
But mastering Bitcoin also makes it clear that scripting isn't exactly for beginners, right?
It's not drag and drop. It requires a good understanding of how Bitcoin works at a technical level.
So it's not something the average user needs to worry about.
Not really.
But it's good to know that this level of customization and control exists within Bitcoin.
Oh, absolutely. It's one of the things that makes it so powerful.
Okay, so speaking of customization and control, let's revisit those upgrades we mentioned earlier, SegWit and Taproot.
Ah, yes, the dynamic duo.
How did SegWit change the game for scripting?
Well, remember that transaction malleability problem.
Yeah, vaguely.
SegWit fixed that issue.
Okay, good.
Which made scripting much more secure and reliable.
So it was like laying a stronger foundation.
Exactly.
For more complex scripts to be built upon.
A solid base for innovation.
And then Taproot came along and took things even further.
Oh, yeah. Taproot's a game changer.
How so?
Well, one of its key features is that it allows complex scripts to be executed more efficiently.
Okay.
And with greater privacy.
So even if a transaction is using a sophisticated script,
right,
it appears more uniform on the blockchain.
You got it. Less revealing.
That's pretty impressive.
It's a big win for privacy and scalability.
Okay, so it seems like Bitcoin is constantly evolving and improving.
Oh, absolutely. It never stands still.
Yeah. But I'm curious, are there any potential downsides or limitations to scripting?
Well, like any powerful tool, scripting can be used for good or bad.
Right.
The book stresses the importance of understanding the code. And the potential risks involved before you go deploying, complex scripts.
So it's about being responsible
Absolutely.
and doing your due diligence.
Always a good idea.
What are some of the security considerations when it comes to scripting?
Well, one of the biggest concerns is bugs
Okay.
or vulnerabilities in the scripts themselves.
So a poorly written script could lead to loss of funds.
That's the worst case scenario.
That's what we want to avoid.
Exactly. So it's crucial to have your scripts thoroughly reviewed and tested before
Okay.
you use them in the wild.
And it's always a good idea to start with simpler scripts and gradually work your way up to more complex ones.
Baby steps. Get comfortable with the basics.
Right. It's a reminder that even with all the technological advancements, human error is still a factor.
Oh, absolutely. We can't escape that.
Okay, so this has been a really insightful dive into Bitcoin security.
Glad you found it helpful.
There's a lot to consider, but the book really does offer valuable guidance on how to stay safe.
It's a great resource for that.
Speaking of staying safe and understanding how Bitcoin works.
Okay.
Let's dive into one of the most fundamental concepts,
Yeah.
and that is building blocks or primitives.
Primitives, the foundational layer.
Primitives, I haven't heard that term before. What are they exactly?
Think of them as the fundamental guarantees that the Bitcoin system provides.
Okay.
These guarantees, they act as building blocks that developers can use to create more complex applications.
Can you give me an example?
Sure. One of the core primitives is no double spend,
No double spend, meaning?
meaning you can't spend the same Bitcoin twice,
Okay, that makes sense.
which is pretty essential for any digital currency.
Right, right.
What other important primitives are there?
Yeah, what else?
Well, immutability is a big one,
Immutability, meaning?
meaning once a transaction is confirmed on the blockchain, it's virtually impossible to change it
Okay.
or reverse it. This ensures the integrity of the system.
So the blockchain acts as a permanent and tamper-proof record of all transactions.
You got a digital ledger for the ages.
Okay, what else?
Another important primitive is neutrality.
Okay.
The Bitcoin network treats all transactions equally, regardless of their origin or purpose.
So it's a system that operates without bias.
Exactly, no matter who you are or what you're doing.
That's pretty remarkable when you think about it.
It is. It's a level playing field.
Okay, so we've got no double spend, immutability, and neutrality. What other primitives are we working with?
Oh, we've also got secure timestamping,
Secure timestamping, meaning?
meaning each block in the blockchain has a timestamp,
Okay.
providing proof of when a transaction occurred.
Okay, and why is that important?
Well, it's crucial for things like auditing and accountability.
Okay, so these primitives are essentially the bedrock upon which the entire Bitcoin ecosystem is built.
You got it. They're the foundation.
And the book really emphasizes how these primitives can be combined
Right.
to create all sorts of innovative applications.
It's like building with Legos. You start with these basic blocks.
Right.
And you can create anything you can imagine.
Give me an example.
Sure, one example is colored coins.
Colored coins.
Yeah, this concept allows developers to assign specific attributes or values to certain Bitcoins,
Okay.
essentially creating digital assets on top of the Bitcoin blockchain.
So you could represent things like real estate ownership
You could.
or company shares using colored coins.
Exactly. The possibilities are endless.
That's mind-blowing.
It is. It's really cool.
What else? What other examples are there?
Another example is state channels.
State channels.
These allow for off-chain transactions,
Off-chain meaning.
meaning they happen outside of the main blockchain.
Yeah.
But they can be settled on the blockchain if needed.
Okay.
It's a way to scale Bitcoin and enhance privacy.
So there's a whole world of possibilities out there waiting to be explored.
Oh, yeah, we've just scratched the surface.
It's like a call to action for developers and entrepreneurs.
Right, to leverage this incredible technology.
To create something truly groundbreaking.
That's the beauty of it.
So this deep dive into mastering Bitcoin has been quite a journey so far.
It has been a wild ride.
We've covered a lot of ground.
From wallets to scripting to security.
And we're not done yet.
Oh, no, we've got more to come.
What can we look forward to in the final part of our deep dive?
Well, we're going to unravel the mysteries of mining pools.
Okay.
Delve into the technical details of consensus mechanisms.
Oh boy.
And tackle some thought-provoking questions about the future of Bitcoin.
I can't wait. Stay tuned for the final part of our epic Bitcoin adventure.
It's going to be epic.
Welcome back to the deep dive. We're in the final stretch of our exploration of mastering Bitcoin, and I'm ready to tackle some of the more intricate aspects.
The nitty-gritty.
Yeah.
We're going deep.
Okay, so let's start with mining pools.
All right, mining pools.
We've talked about mining as this decentralized lottery,
Right.
but the book mentions that most miners actually join forces in these pools.
They do.
Why is that?
Well, imagine trying to win a lottery where millions of tickets are printed every second.
Yeah, your odds aren't good.
Your odds are slim to none, and Slim just left town.
Right.
That's the reality of solo mining these days.
Okay.
The network's hash rate, the collective computing power, it's grown so massive
Yeah.
that it's really tough to find a block on your own.
So joining a pool is all about increasing your chances of winning
Exactly.
and sharing the rewards.
Strengthening numbers, right.
It's teamwork on a massive scale.
It is. It's a global collaboration.
But how do these pools actually coordinate the work and ensure that everyone gets their fair share?
That's a great question. It seems like a logistical challenge.
It is.
But that's where specialized pool mining protocols come in.
Okay.
So miners, they connect their hardware to a pool server,
Okay.
contributing their processing power to the collective effort.
Uh-huh.
And the server distributes the work, verifies solutions, manages the payout system. It's a well-oiled machine.
So it's pretty complex behind the scenes.
It is. There's a lot going on under the hood.
But the concept itself is fairly straightforward.
Yeah, you get it.
Okay, now let's shift gears and talk about consensus.
Consensus, the heart of Bitcoin.
The heartbeat of Bitcoin's decentralized nature.
It's what makes it all work.
We've touched on it before, but I'm still a little fuzzy on the details.
Okay, let's clarify things.
Yeah.
So consensus is basically the mechanism that ensures that everyone agrees on a single version of the truth, the blockchain.
Right, even though there's no central authority.
No one in charge.
Right, that's the beauty of it.
And the magic.
But also where my brain starts to melt a little.
Yeah, it can be mind-bending.
How does it actually work?
Well, it all boils down to proof of work, or POW.
Right, POW.
Which we talked about earlier, remember?
Vaguely, yeah.
The miners are constantly expending vast amounts of computing power to solve those complex mathematical problems.
Yes, burning through electricity.
Yeah, that's the engine.
Okay.
That drives consensus.
But how does solving math problems lead to everyone agreeing on the blockchain?
Okay, so the rule is simple.
Okay.
The longest chain,
Okay.
the one with the most accumulated computational work,
Uh-huh.
is considered the valid blockchain.
So it's like a constant competition among miners.
Yeah, like an ongoing race.
To create the most powerful chain.
Exactly.
Okay.
And because it requires so much computing power,
Right.
it's incredibly difficult
Yeah.
for anyone to try and tamper with it or rewrite history.
It would take an astronomical amount of energy and resources.
It's practically impossible.
That's a pretty strong deterrent.
That's a pretty good security system.
But the book also mentions something called a 51% attack.
Right, the boogeyman of Bitcoin.
That term always kind of sends shivers down my spine.
I get it. It sounds scary.
So what exactly is a 51% attack?
Okay, so it's a theoretical scenario.
It's theoretical, okay.
Where a single entity gains control of more than 50%
Oh, or is it half?
of the network's hashing power.
And if that were to happen?
They could potentially double spend transactions, reverse confirm blocks, really wreak havoc.
That sounds disastrous.
It would be bad news.
So is Bitcoin truly vulnerable to such an attack?
Well, while it's theoretically possible, it's highly improbable.
Okay, good.
The cost of acquiring and operating that much computing power would be astronomical.
Okay.
Not to mention the reputational damage.
Right, and the potential legal repercussions.
Oh yeah, you'd be in a world of trouble.
Okay, so it seems like Bitcoin is designed to withstand even these extreme scenarios.
It's built to last.
Now let's revisit the concept of forks.
Forks, always a fun topic.
They've always been a bit of a head scratcher for me.
Okay, so forks, they're an integral part of Bitcoin's evolution.
Okay.
Essentially, a fork occurs when there's a change to the Bitcoin protocol, the rules that govern the system.
Right, like an update.
Kinda, yeah. But it can happen intentionally, as an upgrade, or unintentionally because of a bug or a disagreement within the community.
Right. And we talked about the difference between hard forks and soft forks.
Yes.
But I'd love a refresher.
Okay.
Like, what's the main difference?
Okay, so think of a hard fork as creating an entirely new blockchain
Okay.
that's incompatible with the original.
Incompatible.
Yeah, it's a permanent divergence like a river splitting into two separate streams.
Okay.
Bitcoin Cash is an example of a hard fork.
So it creates a whole new cryptocurrency
Essentially,
that operates independently.
it goes its own way.
Okay, and a soft fork.
A soft fork is backward compatible, so it introduces a change
Okay.
that's accepted by both upgraded and non-upgraded nodes.
So it's more like an update or a patch.
Yeah, that's a good way to put it,
Okay.
that everyone can agree on,
So hard forks have led to the creation of these new cryptocurrencies.
like Bitcoin Cash.
And soft forks have allowed Bitcoin to evolve
Right.
without fracturing the network.
Exactly. They keep everyone on the same page.
Interesting.
So these forks, they really highlight the challenges and complexities of governing a decentralized system.
It's like trying to herd cats.
Yeah, it can be chaotic.
Well, with code.
Exactly. A lot of strong opinions out there.
But ultimately, this process ensures that Bitcoin remains open and transparent and resistant to censorship.
It does. It's a feature, not a bug.
Messy, but it works.
It does.
Okay, so now for the million-dollar question.
Hit me with it.
What does the future hold for Bitcoin?
The crystal ball question.
I know mastering Bitcoin doesn't offer any definitive predictions.
No one can predict the future.
Right.
But it must provide some insights.
Yeah, like what are some of the key trends and developments to watch?
Well, one of the most pressing issues is scaling.
Right, we talked about that earlier.
As Bitcoin adoption grows, finding ways to handle that increasing transaction volume
Right.
without compromising decentralization or security, that's key.
So we talked about layer 2 solutions like the Lightning Network and research into more efficient consensus mechanisms. Are those the most promising avenues?
They're definitely at the forefront of the scaling debate.
Okay.
The Lightning Network, with its off-chain payment channels, was a way to process transactions much faster and cheaper.
Okay.
And research into new consensus mechanisms could potentially unlock even greater throughput on the main blockchain.
So it sounds like the Bitcoin community is committed to finding solutions that maintain the core principles
They are.
of decentralization and security.
Those are non-negotiable.
Right. While also improving scalability.
It's a tough challenge, but they're up to it.
And privacy is another area
Right.
that's getting a lot of attention these days.
Absolutely. It's essential.
Because while Bitcoin transactions are pseudonymous,
Right.
they're not completely anonymous.
And that's a problem for some people.
And I remember the book mentioning techniques like CoinJoin and other privacy-focused protocols.
Yeah, those are gaining traction.
Right.
Because there's a growing awareness of the importance of privacy.
Okay.
And developers are actively working on solutions to enhance anonymity and protect user data.
So it's clear that Bitcoin is constantly evolving.
It never stands still.
It's not just a static technology.
But living system.
It's a dynamic ecosystem.
Driven by innovation.
Driven by innovation.
And a shared vision for a more decentralized future.
And mastering Bitcoin is a fantastic guide for anyone who wants to dive deep into the technical intricacies of this revolution.
It's the Bible of Bitcoin.
It really is.
It's a challenging read at times.
Oh, yeah.
But incredibly rewarding.
I couldn't agree more.
It's worth the effort.
So this deep dive has been an eye-opening journey.
It has been a wild ride.
What stands out most to you from our exploration of mastering Bitcoin?
You know, for me, it's the realization that Bitcoin is more than just a technology.
Okay.
It's a movement.
A movement.
It's a global community of individuals who believe in the power of decentralization, transparency, and individual empowerment.
And it's a reminder that the journey down the Bitcoin rabbit hole doesn't end here.
Oh no, this is just the beginning.
There's always more to learn.
Always more to explore.
More to explore and more to build.
Bitcoin is just getting started.
So as we wrap up this deep dive into mastering Bitcoin, I'd like to leave our listeners with a final thought to ponder.
Okay, I like it.
If Bitcoin represents the separation of money from the state, what other systems and structures could be transformed by embracing the principles of decentralization?
That's a great question to leave everyone with.
It's a question worth exploring.
It is.
So until next time, keep those Bitcoin brains buzzing.
And keep on learning.
This has been The Deep Dive.
See you next time.